Hello, fourth graders. This is your work for May the 4th. Monday, May 4th. We're going to be on investigation 10, and this is the last investigation that we're going to do for the school year, so I think you should be glad. Yay! Alrighty. Let's go ahead and look at probability. Okay, if you've ever played a board game, if you've ever played, a card game, if you've ever played a game, period, many board games involve an element called chance. This means that when we spin a spinner or roll a number of cubes or draw a card from a shuffled deck of cards, we cannot know the outcome or the result of the event ahead of time. When you pick your card, if you're playing in Uno, if you roll the dice, you don't really know what the outcome is going to be, right? However, we can often find out how likely a particular outcome is. A degree of likelihood of an outcome, thinking, okay, I kind of know that I can get these chances, or I can get this card. For instance, if I got a cube, and I have a cube here, roll dice here, I know that the outcome could be one of 6 things, right? It could be 1, it could be 2, it could be 3, it could be 4, it could be 5, and it could also be 6. Of course, we always want 6 because we want 6 chances to, get maybe to another spot that we want to get to. But the degree of likelihood of an outcome is called probability. You probably heard me talk to the 5th graders about this earlier in the year when we started talking about probability. Those are the chances or the likelihood of calling something or knowing the chances for something. It's called probability. Now on your books there, you see a spinner, okay? Many of you have played a game where you've had to spin before, okay? The face on that spinner that you see there has 6 equal parts, or 6 parts that are called sectors. Each sector is 1/6 of the face of the spinner. Assuming the spinner is balanced and fair, then a spin of the arrow can end up with the arrow pointing to any direction. The letter that names the sector where the arrow lands is the outcome of the spin. For the questions that follow, ignore the possibility that the arrow may stop on a line. Okay, sometimes there is a possibility that the arrow can stop on a line, but you're going to ignore that in the following question. So suppose I had a spinner. This is the clock, by the way, but I'm going to use this. When you spin something, what happens? You either get to numbers 1, 2, or the space that you want. Sometimes they can get stuck in the middle though. So ignore that. If the arrow, let's suppose you had a spinner and it's your turn to spin. If the arrow, and if you see that on your books there, by the way, when I'm talking about the sector, is this right here, okay, this sector. All right. Alrighty, if the arrow is spun once, what outcomes are possible? What you see there in that spinner that would be possible? Okay, well, there's only 3 letters here, okay? The spinner could either end up, the arrow could end up on A, it could end up on B, and it could also end up on C, right? So one of the 3, okay? On number 2, on which letter is the arrow most likely to stop at, and why? If you look at that spinner, it has C-A-A-A-B-B. Now look at that spinner there, and if you look and you notice, there's a letter that is repeated here more than all the others. And what letter is that? It's the letter A. So the arrow will most likely stop at A because the A sector covers more of the spinner than B sectors or the C sector, okay? Number 3, write the possible outcomes of a spin in order from least likely to most likely on that there, number 3, okay? Okay, so what's likely to most likely? Well, what do you mean by that, Mrs. Campos? Well, what that means is what is likely to happen, what is most likely to happen in order there. Okay, if you see the letter C there, there's only one C. There's only one little spot for C. So that's probably likely to happen, but it's not most likely to happen. Then if you look at B, it has 2 spaces, so that's probably more likely to happen, or more likely for the spinner, the arrow to stop on, than the letter C, right? Because there's 2 spaces. And then you have the most likely, the letter A. the letter A would be most likely to, would be where the arrow will most likely end, because there's 3 spaces versus 1 space and 2 space. Okay, so the order of that would be C, B, and A. Okay, which outcome of a spin is twice as likely as outcome C? There's only one outcome of C, and the other outcome of C, the other one that is twice, or the question here is twice as likely as the outcome of C, is B, because C is only 1, twice of that is 2, right? And B has 2 spots there. All right, number 5. If the arrow is spun many times, then about half the outcomes are likely to be which sector? Let me ask the question again. You're predicting this yourself, so think about it. It's not an exact answer here, but try your best to answer this question. If the arrow is spun many times, then about half the outcomes are likely to be in which sector? If it's spun many times, what is the outcome of most of these spins going to be? What are the likely to be in each sector? Okay, it's going to be A. If you're spinning multiple times, it gives more of a chance for the letter A to be chosen because it has 3 spots there. Alrighty, number 6. If the arrow is spun many times, then what fraction of the spins are likely to stop in sector C? What do you think? Is it 1/6, 1/3, 1/2, or 5/6? If the arrow is spun many times, then what fraction of the spins are likely to stop at sector C? Okay, if it's spun many times, what is the likelihood that it's going to stop at C? It's 1 out of 6, right? Because you don't have C as many times as you have A or B. So it would be letter A. In 60 spins, if you were to spin this more than 60 times or 60 times, about how many times should we expect it to stop in sector C? 60 times, think about it. 1 time every 60 times would be what? Okay, if it has 60 spins, what is the likelihood for it to stop at C? So think about it. The likelihood for it to stop at C would be A, B, C, or D. About 6 times, about 10 times, about 20 times, or about 30 times. The likelihood that it'll stop on C, or the times we should expect it to stop at sector C, would be 10 times. Okay, let's go to the next section there. The probability an outcome can be expressed as a number ranging from 0 to 1. An outcome that cannot happen has a probability of 0. An outcome that is certain to happen has a probability of 1. An outcome that could happen but is not certain to happen is expressed as a fraction between 0 to 1. Go with me to the next page there. Use the spinner at the right to answer problems 8 through 10. I'm going to have you answer problems 8 through 10 on your own on a piece of paper. By the way, the other questions that we were doing on paper should be filled out too. I want to make sure that you're understanding this, okay? Alrighty. We show standard dot cube at right. So look at the dot cube there that you see there. We're on number 11 here. What numbers are represented by the dots on the faces of a dot cube? What numbers? We have the number 1, 2, 3, 4, 5, and 6, all on this dot cube, okay? If a dot cube is rolled once, okay, which number is most likely to end up on top and why? Which number do you think, if we rolled it once, what number is likely to be on top? Well, none of the numbers are most likely to end up on top because each number is equally likely to end up on top after one roll. We can't tell. There's not, 2 2s, okay? If there were 2 dots in this dot cube on 2 sides, if it was on this side and this side, the likelihood that it will stop on that would probably be more chances than all the other numbers. So that is the answer for that. Okay, none of those. Number 13. Okay, why don't you answer numbers 13 through 16 on your own piece of paper, okay? And we're gonna do this last part here too. And actually I'm gonna cut this video on to 2 parts for this investigation. So I'm gonna finish this part 1, watch part 2 for investigation 10. Alrighty?